In this video, I'm going to explain to you the 5 different cases that you can have when you're using a spherical mirror. In a spherical mirror, the center of curvature is the point at which you would put, if you had a compass, you would put the point part of the compass here, and you would draw the edge of the mirror there. So it's basically the radius of the mirror. The center of curvature is the distance that corresponds to the radius to the radius of the circle. The focus would be half the distance to the center of curvature, from the center of curvature to the vertex. And in any case, when you want to find where the image is located, you would draw 2 rays. And I've used a black ray and a red ray to show you how they're drawn. Case 1 is where the object is closer than the focus. There are 5 cases. The object is closer than the focus, on the focus, between the focus and the center of curvature, at the center of curvature, and past the center of curvature. So case 1, the object is closer than the focus. We use a mnemonic SALT to describe the image that forms. So S is for size, A is for the attitude, L is for the location of the image, and T is for the type of image. In the first case, you would get the same behavior as you do with a shading mirror that is used to magnify your face so you can see more clearly. We have the object placed closer than the focus, so the first ray hits the mirror and then comes back through the focus. The second ray goes straight to the mirror and then comes back parallel to the principal axis. And what you want to do in this case is extend the ray that has bounced back to show where the virtual image will form. You also extend the other ray that has bounced backwards, and where those 2 extended rays merge is where the image will appear. And in this case, the image is larger, it's upright, it's behind the mirror, and it is a virtual image, which means you cannot cast it onto a screen. You can only see it. In case 2, the object is located at the focus. This is used when you have flashlights or spotlights, or anything where you want to cast out a parallel set of beams. In this case, we see that the object is at the focus, but slightly above it because it has a certain amount of height. The first ray goes straight to the screen and then comes straight back, and the second one goes through the screen and goes back through the focus. And what we see is that the rays are parallel. So no image forms in the case of an object at the focus. The same concept is used when you have parallel incoming rays. When the incoming rays are parallel, say, for example, the rays coming from the sun, they're not exactly parallel because the sun is a finite distance from the Earth, but they're about as close to parallel as rays will be when coming from an object because of its distance. So what will happen is the rays will all converge on the focus. So that concept is used to make parabolic dishes for getting satellite signals and amplifying them. If you have a distant satellite transmitting, then you want to amplify that signal as much as possible by converging all the rays onto the focus where you have a transducer. In case 3, the object is past the focus but closer than the center of curvature. In this case, again, draw your 2 rays. One ray goes straight to the mirror and then comes back to the focus. The other ray goes through the focus and then comes back parallel. Where the 2 rays intersect is where you're going to form your image. In this case, the image is bigger, it's inverted, because it's upside down. It's in front of the mirror, and it's a real image, which means it can be cast onto a screen. It can be projected. Case 4, the object is located at the center of curvature, and the result is the image is going to be the same, but the size will be inverted. Again, you always show it with 2 rays, one leaving the top of the object, going through the focus, and the other one leaving the object, hitting the mirror, and coming back parallel to the principal axis. This is the principal axis over here. Where those 2 rays intersect is where your image will appear. You'll see that the image will be the same size as the object, but it will be inverted. Case 5, the object is past the center of curvature. The image is going to be smaller, inverted, and real, which means it can cast on a screen. As you can see, again, I use 2 rays. One goes to the mirror and then passes through the focus. The second ray goes through the focus, hits the mirror, and then comes back parallel to the principal axis. Where those 2 images intersect, where those 2 rays intersect, is where your image will form.